Welcome to another episode of Clean Critically. Excellent ideas from manufacturers brought to you by the Product Quality Cleaning Workshop. And today we're going to discuss chemical literacy, molecules and mixtures.
Exactly. Last time we talked about atoms, and today we're going to talk about molecules and mixtures.
And here we are. Here's how to reach us. There's Ed, and I'm Barbara, and you've got Darren, and here we are. So we're going to answer the important and critical question of
which is more fun, making molecules or eating dessert?
That's a tough question for me because I like them both.
I do too.
So last time we really talked about the atoms and we focused in on what makes an atom, what makes an element, and so on. So if you missed that video, be sure to go back to our playlist and start at the atoms one. And then today we're going to see how we build everything in nature using these kinds of atoms. And it's helpful to think of atoms like the Lego bricks. So everything you've ever seen and touched, and even yourself, are made out of atoms, just like Legos can be used to make a variety of interesting structures. And so this is how we make a universe. Go ahead, Ed.
Yeah, although there are 3,700 types of Lego bricks, there's really only 118 elements, and not all of those are found naturally.
Yes.
Some of them artificially produced.
I think there are at least that many different kinds of Lego bricks in our house.
Yeah.
Actually, on the floor.
Yeah.
But how do you make a universe? Ions, molecules, mixtures from the 118 elements.
And so if there's an imbalance between the number of protons in the nucleus and the number of electrons around the nucleus, we have what we call an ion, a charged particle. It could be a charged atom or ion, but it could also be a molecule. If there's an imbalance in the number of positive charges and the electrons, then you'll have a charged molecule. And this is really important in cleaning because, especially in aqueous formulations, a lot of those have charges that help with solvation. And then we have compounds. Go ahead, Barbara.
Oh, okay. We get into compounds and molecules. So a compound is a pure substance made of two or more elements. And that would be like our old friend sodium chloride or, yeah, basically
right.
Any of the salts. Yeah.
And I think a lot of times we think of compounds as molecules like water. If you'll go back one.
Go back one.
But a compound can be like sodium chloride, where it's really a network. It's an ionic network. You see all the sodium ions and the chloride ions in this cubic structure. That's the compound sodium chloride. But when it dissolves in water, all of those ions get pulled apart by the water, and you have a mixture.
Yes. And then we get into molecules, which are a bonded collection of two or more atoms. And we are showing you methane representations. And I think it's real important. You can't get a real good microscope and see C's and H4s or ball and stick models. These are all representations of what we think they look like today. So, molecules are fun and very engrossing. And here are some very important molecules used in cleaning. 1-butoxy-2-propanol. It's a modified alcohol. And again, a modified alcohol is important to demystify because it's not alcohol with a little cherry and a parasol in it. It's simply 1-butoxy-2-propanol. And this is a hydrocarbon. When you talk about having an isopar blend, these are hydrocarbon molecules, and there could be lots of different molecules in that isopar mixture.
Notice if you go back, all of those have 8 carbon atoms, and so there's all different versions of octane.
Yes,
that's a great point.
Yeah.
And actually, the hydrocarbon blends is a cut, and it's more than C8, the 8 carbon blend.
Right.
Do you want to talk about iced tea, Darren?
Yes, and so like that one with octane, it had all of those different molecules in it, so that's a mixture. Anything that has a variable composition,
yes,
that the composition, if that composition is the same throughout, we call that homogeneous. It's the same throughout. And so in this case, we have hot tea. Everything's dissolved in the tea. And the way we think about homogeneous mixtures is if you sample it at the top or sample it at the bottom, you get the same ratio of the different components. Whereas in iced tea, that's heterogeneous, because if you sample at the top, you get a cube of ice. If you sample at the bottom, you get tea. Or if you're down here in Texas and you got a layer of sugar at the bottom, you sample at the very bottom and you get mostly
Yeah,
sugar. So
that's
that
dessert.
would be a heterogeneous mixture.
Yes, again, to me, it would be dessert and very heterogeneous. Been there. It's very good. So the issue is, can chemistry, as represented by these Lego blocks, compete with dessert? And we'll find out a little more later.
And dessert is a little bit of, it can be considered a mixture in this case.
I
That's
would
right.
say
And it's definitely a heterogeneous mixture. If you look back at that
absolutely.
beautiful picture, we have a nice warm brownie. We've got the nice cold ice cream. Depending on where your spoon goes,
And
you'll
how
get a
much you mix
different
them up.
composition
Yeah.
and different physical properties. So this
Do you want to show
applied to,
that heterogeneous mixture again for
Oh,
a minute?
sure.
Yeah, that's
yes,
the nepotism slide. That's a
Yeah.
that's
grandchild.
right.
Yeah.
And that's just wonderful. You know, you get all of the different physical properties, the cold and hot, the the creamy versus the crunchy. I like the corner piece on the brownies.
Yeah.
Me too.
And just like the spoon on the plate, you get a different result depending upon where you sample. Even in a cloudy surfactant that's sort of hit the cloud point, or the temperature's gone below the cloud point in the surfactant, you've started to get phase separation. Now, it kind of depends on the size of your spoon in terms of whether this would be deemed heterogeneous or not, but it is starting to phase separate. And so we would call that a heterogeneous mixture on the right, and on the left, that homogeneous mixture, the surfactant. Above the cloud point, it's all uniform, and it's a homogeneous solution.
So it's really important to understand oil splitting cleaning agent, which means the oil layer is on top, and mixtures can change during cleaning. This is a
Mm-hmm.
heterogeneous mixture where you have phase separation, and the oil splitting cleaner is the oil layer on top. In working with that, you have to understand about removing that oily layer, or it's like skimming chicken soup and you're going to get fat right all over the part again, and you'll get
That's
oil
right.
right on it again. So, yeah, it's important to understand moving forward about chemical reactions. And we've given a little introduction to molecules, but molecules can interact through chemical reactivity. They can build up bigger compounds, break down into smaller ones, or down into the elements. And chemical reactions can be natural or man-made, good or bad. And some examples.
Let me say something to that. You're doing chemistry in your cleaning baths. There are reactions taking place. And we even showed at one of our workshops how cleaning got a little bit better when we introduced a bit of soil, because there was reactions going on, and it tend to season the bath a little bit.
Because it gets into like dissolves like. So the soil that was dissolved or perhaps suspended in the cleaning bath acted as
A cleaning agent.
as a cleaning agent. And I've worked with an old time formulator, really old time formulator, who once tried to market cleaning agent with a little bit of soil in it so that it would work better. And the marketing department was not thrilled with the idea, but it was a thought. I think it was a good thought.
Yeah.
So there are lots of examples of products of chemical reactions: flowers, people, rocks, plastics, hydrofluoric acid, PFAS, and dessert. Because there's a lot of chemistry in cooking.
That's right.
What are your next steps?
Well, you should be aware of chemicals because they are everywhere. It's not magic. We're made of chemicals. Everything else is made of chemicals, including the cleaning agents that we use to clean, whether they're water-based or solvent. The important thing is develop chemical street smarts for you and your company.
And I think that's really important because we're getting a lot of company-wide or corporate-wide orders to switch from one chemistry to another, and simply switching that may or may not be a good idea. Sometimes it is, but switching to another chemistry does not necessarily mean that you're better or safer or better for the
Sometimes
environment.
it makes good press, but not necessarily a good product.
It
That's
has to
right.
be absolutely right. It must make good product, and it must not damage your employees or the environment,
Yeah.
and it must let you to operate productively and profitably.
And this quote
So
from Lee Rensberger really captures that. He said that after taking our course, he has a much better understanding about why the cleaners work good or bad. I mean, he's thinking
not
about it
just
from a
him.
molecular
He's
standpoint.
I got to
talking,
interrupt you. He enrolled his tech.
That's true. His tech.
And
That's
I
right.
think that's real important because lots of times we tend to think of educating, of training the techs as if they were monkeys or some lower life form, perhaps amoebas. And, as soon as you change the process, you've no longer trained your employees.
Hmm.
You educate them, they can help you for a long, long time.
Yeah,
But I
that's
love,
great.
yeah, he his tech wants to understand the science behind the cleaning, and I think that was really cool.
Yeah,
In
that's
our
great.
experience, that makes for a better, more consistent process. They're
And
not
that's why
going
we're talking
to.
about atoms and molecules. I mean, this is the science behind the cleaning.
yeah, and you can get information on this course on the PQ said the
EQC.
PQCW website.
So we've come to the conclusion, based on a 7-year-old, that both molecules and dessert are really important, and I would tend to agree. And I would say that there are complex molecules in dessert as well.
Oh, yeah.
And of course, there are polymeric materials in the Legos.
Yes. So hopefully this has been enjoyable for you. We've covered the atoms and ions in the last one, and molecules and mixtures in this one, and then the whole playlist. So if you don't mind, like, subscribe, and go to that playlist and see all of the other Clean Critically episodes in this series. We think you'll enjoy them.
And here is an attempt to say clean critically, clearly, really
That's
quickly.
right.
Till
That's
next
right.
time.
Yes.
Bye-bye.